Well, good morning, everybody, and welcome to Ellensburg, Washington, USA. On a beautiful, breezy, late spring morning. Today's date is May 20th of 2025. So great to have you with us today. How's everything going out there? Is everybody ready to do a little bit of work in the classroom? Looks like we're loud and clear. Wonderful. Hi, everybody. How was the weekend? Are you ready to dig into Gary Smith literature? The drinking word is Gary, both today and Thursday. I hereby declare. Let's get you on the iPad, talk a little bit. I have a couple of thank yous, actually, as people stroll in here. We have more than 150 live viewers. If you're watching this in replay, our lecture will begin in about 8 minutes from now. Good, we're communicating. Where are you viewing from this morning, this afternoon, this evening? Here in late May. Canada. Bern, Switzerland. What up, homie? Delay in the comments. Forest Grove, Oregon. Leamington Spa, UK, Hillsboro, Oregon, Yosemite, California. Hello, Sean. Billings, Montana, Chelmsford, England. Hot, Orlando, that's Geology Grandma. Springfield, Oregon. Tagish, UK, that's not UK, Yukon Territory. Martinez, California. Fort Vancouver, Mainz, Germany. Chesapeake, Virginia, Southwest Georgia. Rose Canyon Fault. Okay, well, that's Oscar, so that's one of my two thank yous. So Oscar from San Diego, thank you. Oscar sent some special chalk that possibly will be luminous. It's the very fancy Japanese chalk. So thank you, Oscar. We will break this out and use it on the chalkboard today. Thank you for your generosity. And not to be outdone, this beautiful card and package was just simply in my office. And it's from Carla. Nice things, nice things. Very meaningful card. Thank you, Carla. And Carla, I don't know anything about you. I guess that was the whole point. But Carla gave me this beautiful gift of the Stewart range. Some sort of wonderful print. I don't know the detail of who did the print, but Carla took the time to post this poster on a frame of some sort to hang in my office. So thank you for your wonderful gift, Carla. I do appreciate it. I love you too. Okay, folks in the room have quieted down because they're eavesdropping. Let's stop that, and I'll turn you around, and we'll just give you a shut out the window again. We'll just get some life back in the room. They can stop listening to my conversation with you. Thanks for joining us today. Indigo.
And I forgot to print the paper again. I'm sorry.
You apologize within the first 10 seconds of being in the room. We got to work on that. No apology necessary. Oh, you guys are looking out the window. Doy. Sorry, that's my bad. Doy. You can probably see this better now. Oh, made in Korea. Sorry, not Japan. Not Japan. Pretty quiet in here. Let's crank it up. Come on, let's go. Guess what happened? We all had ice cream and you didn't. Did you hear?
It was laced with
It was
meth.
laced with meth. That was the hook.
Sounds like something Gary in New Mexico would
Yes,
experience.
Gary in New Mexico. Exactly. Did you just watch Gary in New Mexico?
Yeah. I watched him in February. I just didn't remember everything.
Oh, yeah.
I did.
No, seriously, yeah. I mean, I guess he might be listening at some point, but like, I didn't get much out of it in December when we did that, and I got a lot out of it now that I'm actually motivated to listen carefully. So there was a lot in there, but yeah, so same. Didn't mean much at the time. Means more now.
Is that a railroad striped shirt? Should have wore that Friday when I wore my railroad overalls. I like it.
Thank you. Are we 5x5, everybody? We got chit chat now. I won't talk very loud to you, but are we 5x5? The scene cam. Yeah, boy. Morning.
But then today we have the field trip to Ellensburg. We're gonna go do a hiker survey.
Ready?
So a pun walks into a bar and kills 10 people. Pun in, 10 dead.
Ooh. Ooh. Burp, burp. Good morning, everybody. Good afternoon, everybody. It is high noon. We begin today's session. There's not that many of these left. When we're together, we maximize our effort. We've got a lot to talk about, and I've already heard from a number of you visiting my office and seeing you in the hallway, and you're like, yeah, I kind of like that one. I kind of like that Gary Smith paper. I'm kind of into it, surprisingly. Like for the first time, I'm actually enjoying it. Okay, I maybe heard more along those lines. I am too. There's a lot here. I was down in Selah yesterday. Ryan visited your mother. She says hi. Everything is wonderful down in Selah, in the Weenass, in the Nile area, and that's where we're going today. Like, I don't know where we're talking about. There's plenty, including geography, that we have to lay down. But a bold open is beginning right now. Oscar from San Diego has sent in some particularly vibrant chalk. Made in Korea, no big deal. Thank you, Oscar. And we are blue this week. We are firmly blue, and you know that by preparing for this week. Gary Smith, Gary's the drinking word. In fact, do you have a drink? Let's do it. Gary Smith? Here's to Gary Smith. Here's to Gary Smith. May he rest in peace. No, he's still with us. Gary Smith. There are about 7 Gary Smith papers, all from essentially the same year. Like that guy was on fire when he was here in the mid-1980s. You are responsible for 1 and 1 paper only. But Gary is saying you got blue in the upper Ellensburg. And it's not just a little bit, and it's massive amounts of blue. It's Cascade rock. Specifically, it's Dacite. So we have to learn together what Dacite is. This big cobble James collected when he was a cute little baby freshman, and now he's a grown man. And he says, yeah, I remember collecting that out by Thorpe. I am new to discovering the significance of Dacite. This is a lecture entitled Dacite on the Move. Dacite on the Move. And there are some open questions that tie specifically to what we did last week. Even though we were red last week, we're going to follow some of those themes. You're still waiting for a bold open. Here it is. There's a hell of a lot of blue dacite in the upper Ellensburg, down here in the valleys, and there's hardly any blue dacite up in the Cascades. There's essentially none. You really have to hunt for essentially missing bedrock of the right chemistry and the right age. And so I didn't realize until this weekend, reading the Gary Smith papers, that there's a major mystery because there's a noticeable lack of source of these rocks we're talking about, not just today, but on Thursday as well. There, I think we have it. We have it settled in, we're locked in, and I have all sorts of drawing that I want to do with you, but I know that you're going to be wanting to talk a fair amount as well. That's the end of the bold open. Let's go right away to talking about what dacite is. Let's do some geography and a few other things. I think the first thing I want to do, improv time, I think the first thing I want to do is to screw with what we did last week. I want to, so we are firmly younger than 11, we're fine. Younger than 11, we know that. The rest of the quarter, except for the field trip with Andrew Sadowski this Thursday, we're younger than 11. We're younger than Elephant Mountain. We're younger than Pomona. We're younger than Grand Ronde. These are lava flows that are going to keep coming up, but we're younger than all that. I want to, and you're like, don't change it, I have it written down. It's okay, I'm just going to move it. I'm just going to move it over here. I just want to move it over to the east, because you know what red means. It means Cascade no. Red means Cascade no. And we were looking at some sands, the Snake River sands of Lydia Steisch. And by the way, thank you. I already have you locked in. I don't have to work any harder to get you. I have you. So I got an email this weekend from Lydia. She said, I'm sorry, I got your email, but we were so busy in southern Idaho at Lake Idaho, I just didn't have time, and I couldn't do a Zoom from my motel room. So this is Saturday. She said, but it was perfect timing. I have a new Hell's Canyon paper coming out this week. Well, you got to be kidding me. She's like, no, it's perfect timing. I just watched what you did with the students, and let's do a Zoom interview this Friday. So we may double back on the Lydia Snake River sand story and some new data, like literally coming out this week. But let's not go there now. So the red, I'm just moving over here because when we do have red, when we do have no Cascades, then we're bringing stuff in from the east. We're good. But I warned you of this, didn't I? I warned you that if we just keep staying in this 11 to 3 million year time window, we're not leaving, and we're just adding new stories to that window. You remember me saying that. So Gary has got, for the first time in this class, what I thought we were going to do in the whole quarter. I thought we were going to be nothing but blue. I thought the entire Ellensburg, barely Ellensburg, lower Ellensburg, upper Ellensburg, I thought it was going to be all Cascade, yes, blue. But it's not. But we're finally to that part. And we want to look carefully at the details in this blue area. Good? I think today at least, but maybe this week and maybe beyond, I think we're 11 to 7. So if the word today is dacite, and it is, the drinking word is Gary, but the actual word, the geology word is dacite. I think we're just absolutely dumping dacite into these valleys around the Yakima, Washington neighborhood between 11 and 7. And this may change, but I think what I'm reading is that there essentially is no dacite coming into the basins before 11. And even more shocking to me, I think what I'm reading, and I'll be interested to hear what you have to say, I think once we get younger than 7, the dacite valve is off. So let's work with that we have boatloads of blue dacite. You know the rocks aren't literally blue, but you know that I mean they're coming from the Cascades between 11 and 7. And to double back on the bold open, there essentially is no dacite 11 to 7 up in the Cascades, like where it would come from. There's only one little spot. Anybody want a brownie point right off the bat? There's only one known spot in the Cascades that's bedrock near Yakima that actually is blue dacite up in the Cascades. What mountain? It was a gamble. You want to try? You can't random yeah. Oh, that was from, he mentioned Hood in the interview.
Oh, I said Snipes.
Snipes. Okay, yeah. Old Scap Mountain. Let's just go ahead and write it down. Oh, he took my answer. I had it. I was just warming up my wrist. I was about ready to come up. It's probably buried deeply in the paper that you read. Old Scab Mountain, I think, will be highlighted. And I don't know, maybe we finish our field trips by going to Old Scab Mountain, which is the source, which is the actual kind of smoking gun. But so we're heading there roughly. Okay, so are we okay so far? I kept this on the board because I think we're going to be playing down lower here with Andrew on Thursday. Otherwise, I would have erased this. Yes?
Is 7 million years ago the marker between the quartzite and the sand, or is it somewhere in the middle of the sand?
All I'm saying with 7 is that apparently our blue dacites, which we're going to look more, that's the whole topic today, we're just going to shut that dacite factory and dumping activity at 7. The quartzites are over here in red, and I don't think we can make any connections like you're wanting to do. Thank you for your interest there, but I'm done thinking about red for this week and maybe for the rest of the class, except for maybe Lydia's conversation on Friday. Okay, I think I want to, okay, now that I said that, I'm going to change my mind. I want to do something here. Good, loving the energy. It's late in the quarter, but you are bringing the heat here today. Oscar, chalk, Korea, red, blue. Let's go. And white for geography. Ellensburg is here. Yakima is here. We know this is the Cascade Volcanic Arc. It's blue. What if I do this? What if I do this? And on a map of Washington, show these aprons of blue. These aprons of volcaniclastic sediments. And I think we'll be specific. That's going to be your part. You're going to tell me what's in these papers and the detail. I'm just giving some broad strokes here. But grouped loosely, we have a bunch of blue aprons of stuff coming out of the Cascades. And again, for today, I think we have this very specific time window of 11 to 7. I'm really curious about that, but for right now, that's what we'll roll with. But red is coming in from the east. Cascades no. And what were some examples again, please, of red stuff we've talked about it with any age in the Ellensburg Formation? Just give us some specifics. What's that? Muscovite coming from the north. More. What kind of quartzite cobbles? What else? Cougar Point tuff stuff coming out of the sky. It's all coming from the east. It's all coming from not the Cascades. Good. And yeah, we're interfingering back and forth. Oh, should we? Why not? Let's do, oh, this might work. So that's such a simple map that we're probably not going to do much with, but I drew this morning over scrambled eggs, and I think I like it. It's going to tie, so there's 3 components to this map: Cascades, Blue Apron, and Red Apron. What if I try to draw a cross-section of the same thing? Cascades, and let's not be crazy. When I draw the Cascades like on Mount Rainier, we remember now during this time frame we're talking about this week, the Cascades are very low. They're subdued. But I guess I'm just drawing it cartoonishly just so we can remember it's the Cascades. Yeah. Oh, let's do that. So this is a cross section. Blue Cascades, yes. Red Cascades, no. And CWU is right at the crossroads. This is going back to the first day of class. I didn't use colored chalk. And if you remember the sketch on the first day of class, I wasn't really talking about volcaniclastics coming from the east. I was talking about the Yakima basalts themselves. So if you like, that could have been another answer to my question. Technically, even the basalts themselves, are Cascade no. Even the Cascades themselves are red, or I guess purple I was using for a while. But are you kind of seeing now cartoonishly that we have this battleground? And I think it's important to keep this in mind because there's places where just between here and Ellensburg we might be in some blue, and then we go a little further south and we're in some red, and you're like, what the fuck? And then we're blue, and then we're red, and the reason for that is we have this both in cross section and in map view. I think you see what I'm trying to do. We're interfingering underground, and we're interfingering on a map pattern as well. All sorts of bleeding together of these two colors. Reaction to this in any way, really kind of setting up our detailed discussion. Anybody? Feeling comfortable? I hope that's the case. Jackson.
The uplift, is this sort of occurring right in this middle of the cross section? So you get kind of the uplift right there.
Okay.
What's causing all this?
I love it. I love it. Thank you. Jackson's remembering one of our major themes, especially on Thursday, was, what was our question from Thursday? And I was pushing one number as the most elegant and simple way to talk about this. Indigo. Question mark. I was asking, are the ridges, the basaltic ridges that are here, and the Cascades themselves, I was asking on Thursday, does everything start 3 million years ago? And I think maybe what you're asking right now, Jackson, is this story of blue and red kind of overlapping on each other a hint that maybe 3 is too young? Because remember, I'm probably taking it farther than you wanted. Maybe not. Remember, at least for this week in Gary Smith's work, this is mostly dacite. On the move, meaning it came out of the Cascades and got sent down into the valleys. Were you really wanting to go that far, Jackson?
Oh, yeah.
I like it. Nice. Oh, yeah. Yeah, I was. I'll go ahead and say it. I was going to save this for Thursday, but Jackson wants to go here now. Okay. This is going to be a big moment. I'm doing this Zoom interview with Lydia on Friday. I'll probably have you watch it over the weekend for next Tuesday, I'm guessing. She couldn't send me the paper because it's not official. I think it's coming out today. But she sent me a couple of little abstracts, paragraphs. She's got Hell's Canyon starting younger than 3. She's got it younger than 2. So those guys are really pushing younger and younger and younger. Now that's just Hell's Canyon, and I have no idea what the evidence for that is. But Jackson, I think if we look carefully at Gary's work, he's saying we're dumping a bunch of dacite because we're uplifting between 11 and 7. And now maybe his dates are all screwed up. He's using dates from 50 years ago. And we'll talk about that starting today. How do you get dates in this pile of Upper Ellensburg? So there is ultimately a tie to this uplift story. It seems like we're on a totally different topic. We're in a different color. We're in a different place. But we're not. We're still ultimately talking about uplift. And I think it's fun. A few more broad questions, and then I'm coming to a bunch of you with detail that you have from Gary's interview as well as the paper that you read for this session. Gavin?
Maybe 3 is still significant, but maybe it's because the rate of the increase is faster then?
Gavin says, why can't everybody be happy? Why can't we do some slower, maybe less interesting, less exciting uplift between 11 and 7, and then why can't we have an accelerated dramatic uplift younger than 3, maybe even younger than 2. I think that's what you're saying. And sure, I want simple storylines that work for everybody. But maybe we don't need to be that way. Right now, from Gary Smith's work, it looks like there's an older uplift story, and that's why we're having so much material come in. But what was, to revisit, okay, I'm feeling like playing now. What was another explanation we had for all this stuff coming into the basin? We did it just kind of verbally. I don't think we drew anything. Instead of uplift sending a bunch of stuff into the basins, what was another explanation for why we suddenly have a bunch of stuff coming out of the Cascades, Jackson?
Was it the deformation of the hot spots slipping under and sort of reworking all the river pathways, which caused different sediments to get kind of put in different places?
Thank you, but I don't know if the hot spot's anywhere close to the neighborhood at this time. I think I'm just talking about Cascades themselves, and we clearly have a bunch of stuff coming down and filling this basin nearby between 11 and 7. If it's not an uplift story, Joe, what's another possible angle? Maybe we're just turning on some sort of volcanic system randomly, it appears, in the Cascades, and suddenly we're just having eruption after eruption, and we're having all sorts of very exotic, explosive stuff. We just are providing a bunch more material suddenly. And again, Gavin, maybe we don't have to pick between those two. Maybe it's a combination. Faye?
I'd like to know more about dacite and what it actually is.
All right, Faye is the new Raquel. So Raquel last week was like, okay, monkey, now start talking about this. And I did. All right, she was just like goosing me along. Faye wants to do that right now. Okay, your wish is my command. Thank you. Let's use this board, which we're going to ignore the map. Let's do this together. Geology 101. I'm going to make a bunch of boxes. Igneous rock classification chart. Let's go. I've got 45% silica up all the way up to 75% silica. We have volcanic rocks in the top half of this. We have plutonic rocks down below. What's here? Gabbro, thank you. Let's keep going left to right with the plutonic rocks. Gabbro, and then I'm down here, plutonic igneous rocks. I have 4 boxes. What's here? Diorite. What's next? Okay. I choose tonalite, which is not a common word. I think you could also say granodiorite if you like. And there's probably a splitting hairs difference between tonalite and granodiorite, whatever. And what's over here? Granite. Okay? But Faye wants to know about dacite. What's up here? What's the volcanic equivalent of gabbro? Basalt. you know that rocks are getting overall lighter colored as we go left to right. There's less mafic content, there's more felsic content. What's here? Andesite, correct. Mumble, mumble. What's next? That's dacite. And then rhyolite is over here. So I admit, I've been here 35 years. I admit that I have not really used the word dacite very much for volcanic rocks in the Cascades, or even down here by Thorpe and down over there by Weenass and everything else. I would just always call it either andesite or rhyolite. But I'm being careful now because Gary is so careful talking about this mysterious dacite showing up, and Faye says, you still haven't told me what it is. Well, igneous petrologists, we have plenty in the room. How can I tell the difference between, what's a key mineral that I can find in a rhyolite versus an andesite? What's a key mineral? Potassium feldspar. I think I'll just do it verbally. So there's plenty of potassium feldspar in rhyolite. There's plenty of quartz in rhyolite. And there's hardly any black mineral content in a true rhyolite. Hannah Sham Lu was out with me a few times this summer making videos. And I'm like, wow, check it. No, the one time I'm thinking about, we weren't making a video. We were just checking out some of the Ellensburg formation. I'm like, check out all these rhyolites. This is amazing. She's like, rhyolite's pretty rare. I'm like, it is? She's like, yeah, rhyolite's pretty rare. I don't think you're looking at rhyolite. I'm like, oh, okay. It's probably a dacite. I'm like, whoops, okay. So what's in andesite? What's a key mineral in an andesite? Hornblende, correct. Hornblende is black, it's long and thin, it's got two cleavage planes, 60 and 120. The dacites are here. I went out to Thorpe this morning, found a bunch of hornblendes, and this that James collected 4 years ago also has some hornblendes in it. But I could be proven wrong, but I think dacites have quartz and hornblende. It's like an andesite with some quartz in it. That's what I view a dacite. So we're not memorizing a color necessarily, but you've read in the paper today, you maybe were confused by the word, monolithologic. What does that mean, monolithologic? One kind of rock. I've got this huge deposit. There's one kind of rock. The monolithologic is dacite. So we are slowing down and making sure we know what dacite looks like. And again, in case you're missing the hook for this, I think we're going to go visit some Upper Ellensburg the 2 Thursdays we have left after Memorial Day weekend. We're going to be on the hunt for dacites. And I think casually I'm going to be on the lookout for dacites in the Upper Ellensburg right after Memorial Day weekend. And then, I don't know, I might change my mind, but I think we're just going to go to Old Scab Mountain and find some dacite in the Cascades, bedrock, that perfectly matches. And if this shit's so distinctive, it'd be satisfying, I would think, to see a whole mountain made out of this stuff, as well as all these cobbles and everything else. Does that work for you, Faye? That's dacite. Very good. Okay, now it's your turn, I think. I think I want to go back to some of these maps, and I want to get some detail from Gary. And I think at first glance, I just want to hear a bunch of just things that you found interesting, and then it's my job to mold some of this into a narrative for us in the second half of today. The floor is yours. Paper, interview, tidbits. Ryan.
That the eruptive behavior between what fed like here in Thorpe and Kentas is different than what fed Natchez.
Shock to me. Embarrassing to me. Correct, Ryan. So Gary is firm that the Upper Ellensburg in our valley by Thorpe has a source that's different than the Upper Ellensburg down by Yakima. I made videos saying that the source of the stuff of Thorpe came from down by Bumping Lake. So I don't know if I found something later than Gary's work or I just totally blew it. I'm not going to pull the video down, but yeah. Yeah, interesting to me too. You caught that. Nick?
I'm not sure if it's just because times have changed, but it says here that right from the top of the Pomona is the Upper Ellensburg instead
Yes.
of what we have as the Upper Ellensburg.
Thank you. I'm glad I kept this. This is what I want to do today. The rest of today, I want your reports, kind of demonstrating that you did your work. That's great. And then I react to it. And some of it I had planned on doing anyway, and some of it I'm truly just spitballing off of what you're doing. That's not just the past, that's real. So there's confusion about, okay, have I hit this hard enough yet? This upper Ellensburg that Gary's talking about, he's thinking is roughly between 11 and 7. Okay, I want to say something real. This is important. How do you keep track of time if you have a bunch of river deposits and volcanic lahars that literally are changing? They're like shapeshifters. You find them in one canyon and you go, okay, I've got that stratigraphy, and then you go to the next canyon over. I'm like, it looks totally different than what this other canyon just was. I can't correlate anything. So how do you, this is in the paper, how do you, what are you hunting for in this pile to have any hope of doing a regional correlation? There's really just one answer, I think. It's not easy. Ryan?
Was it
The
the facing?
facings. He was...
You have like your specific facies for each?
Oh, facies. I think that's the problem. I think the word facies is just saying as you work your way laterally, the facies changes, and we go from a floodplain to a main channel to out of a river scene at all, and we're battling facies changes. But my question again is, what's the only thing that I think Gary was trying to find? I'm not sure he did find much of, and it's a clue to what we did a couple weeks ago. James. Thank you, but no, possibly, but to me the basaltic conglomerates I'm ignoring, because those, anytime you have a conglomerate with a bunch of pebbles made out of basalt, that's a very local story, and we're simply knuckling up one of these ridges in a bunch of detritus. A bunch of basalt is just spalling off this uplifting knuckle. And I don't think it has the lateral extent we need to correlate. We just basically have a big sandbox, a big blue sandbox, and I thought we'd have it by now, but I want to keep going with you. Like, I want something, I want 3 heavy blue lines that I can follow, ideally, from Ryan's backyard in Sela all the way up here to Thorpe. Scene. Kinda. Luke.
Didn't he say he was doing like geochemical dating? He said he got some grants from the DNR down in Olympia.
He did. What was he looking for, though, to sample? We don't have it. Airfall tuff. Airfall tuff. Does this sound familiar? This is Barb. This is Barb country. This is Barb blowing our minds by saying, yeah, you have a layer that all fell out of the sky at precisely the same time, and oh, by the way, it's from Idaho. We're not that greedy this time. Every once in a while, buried in his descriptions of some of these units and those little stratigraphic columns that you saw in the paper, and even verbally in the interview, he's like, I was really looking for this airfall tuff. And if I can find an airfall tuff and I can sample it properly and I can find it from one side of this basin to another, then I can keep track of time. And for all I know, and he's willing to probably say this too, for all I know, this could be 12 to 6 or 12 to 5 or 7 to 3 or whatever. And that gets back to what Nick was just saying. There's different lavas, Nick, that are at the basement of different sections. So some of the upper Ellensburg that Gary was looking at is sitting directly on top of Pomona. And Pomona is the dip slope as you many of you know the drive to Yakima. You go up, you're on the freeway, right? You're coming up and over three major ridges. You cross that last ridge and you can see Sela, you can see Ryan's house, you can see Yakima, the rest area is coming up. There's that beautiful Fred Redmond Bridge. That's what's known as a dip slope. That's a sloping layer that's truly Pomona. And Pomona was flat, but it's been folded up because of the Yakima fold belt. It's beautiful. It's rare to have a dipping lava flow that truly is the surface that you can hike right up or drive right up. The freeway goes right up it. So the point is, I'm getting excited now, and I'm not answering your question directly. Here's the third time to try to comment on your question, Nick. In some places, the blue sandbox is directly on top of Pomona. In other places, it's sitting directly on top of Elephant Mountain. In the case of Nile, that's a video I'm going to be sending you before we quit, it's sitting on top of Grand Ronde. Again, these lavas are not all covering the same amount of real estate as the others. But if you got the blue stuff sitting on directly on top of Grand Ronde, you could be way the hell down here in time. Or you might be way up here in time, and it's just a major unconformity. That's why these airfall tuffs are important. And I was just talking to Hannah over the weekend. She's like, I'm like, Hannah, are we doing the speaker series again next year? She's like, yeah, I think so. I said, can we please invite a speaker who can be blindfolded? That's number one. And then can we take that specialist in volcaniclastic deposits and take them out to Thorpe and take the blindfold off. And then put the blindfold back on. Take them down to many of these places that Gary Smith was working on. I want to know how to interpret all these details in this very complicated volcaniclastic pile. And I ultimately want to know, what does it look like when you have stuff falling out of the sky? It's not all as perfect as that quarry we all saw at Cougar Point Tuff. That's like, maybe that's the first airfall tuff you've ever seen. You're like, oh, cool, they're all like this. No, they're not all like that. There's not 30 feet of it that you're breaking open with a hammer and accretionary lapilli. Give me a break. Like, you all saw it last Thursday. How many vehicles were there? Like 6 or 7? Yeah, we didn't even have enough parking. So everybody's going apeshit over we had that same accretionary lapilli in the Cougar Point Tuff 7 at Weenass Lake. It's rarely that perfect. But still, there are reports from Gary and others that there are these airfall tuffs, these layers of snow. Let's just call it that from this point on. If we go out and start looking at this, I'm like, do you think this is pure snow? What am I saying with that? Okay, I'm really having fun now. If that's so rare, if we're looking for these, let's say, 3 layers of perfect, pure snow that just fell out of the sky and nothing happened after that, what am I implying about all the rest of the sandbox? I'm saying the rest of it's not like that, so what happened?
River.
It got reworked. It got reworked. You take that snow and you start moving it and sloughing it and digging in and messing it up, Indigo. Thank you. We also saw that at Weenass Lake. We're like, we got these fragile little pumice, these soft pebbles and everything, but like, is anything primary? Is anything like from the actual deposit, or was everything screwed up later on? More from Gary. This is fun. This is not the order I was planning on going, but I want to go with it anyway. Faye.
One thing I was interested in was he was talking about the ratio of andesitic material to basaltic material increasing as he went up. I think he was talking about Natchez. And then he mentioned that this suggests unroofing during uplift.
Oh, yeah.
I've never heard of what unroofing is.
Okay. Shit, should we do it now? I don't think we should do it now. That's a major story. So if you got to the, maybe you followed my instructions and read the abstract 3 times and looked at the figures and you liked a couple of the maps. We can talk about those maps if you want, and the captions to the maps. And then maybe you read the conclusions twice. In the last paragraph of the conclusion, he's talking about roofing. That's what Faye's talking about right now. Unroofing. That is a major story that I think I want to take the time to do on Thursday. It's a big deal. And it deals with Jack's uplift, and I am going to wait until Thursday because I really want to lay that out just right. But if you're curious about it, reread that unroofing business a little bit more. It's okay that you were confused. That was a complicated thing. But I was down with some old timers yesterday and they were showing me some exposures on their ranches by Sela. And I explained it verbally just as like a test run to those guys. They're like, oh yeah, got it. It's like, wow, really? You can follow that? Like, yeah, makes perfect sense to me. So I was encouraged that just verbally talking about that, should I do it now? Let's keep going, let's keep going. Nick, on fire today.
So I wanted to ask, because it seems like it contradicts itself, because it says...
By it, do you mean Gary Smith?
Yeah.
He's a person.
Sorry.
You listen to him.
I meant the paper. The paper contradicts itself. It says...
The piece of...
Lava dam lakes were not major contributors to the stratigraphic record, but then at the end it says, hold on, wrote it down. It says the complex stratigraphy is the result of active tectonics and volcanics. But if it's not a major player in this stratigraphy, then why would it still be a major player in the complexity?
Thank you, Nick. I think one of the benefits of the paper is that it was almost reviewing some of what we were doing in this class, right? He was going quite a bit older. He was talking about lavas coming in. He was talking about ridges growing. And then he was also talking about today's subject, which is really not a major deformation story necessarily. So I think it was just the scope of the paper where you started getting conflicting signals. I think earlier there were some narratives that we're losing as we go later. And Yaffe, I like the idea is if we have a sandbox, if we have trends, what kind of trends do we have? Are we getting more and more basalts? Are we getting less and less? Are we getting more dacites, less dacites, everything else? And again, if it was the Grand Canyon, I'd be fine because we can follow the layers from Arizona to Mississippi. But here, you can't even follow the layers from one county to the next without them changing on you. They're almost like camouflaged. You're deceptive. It's complicated. There's a reason I've avoided the Ellensburg formation to this point. This is year 34 of teaching, and I'm just now starting to deal with it. Like I've been afraid of it. Raquel, I'm afraid of you too. What do you have to say?
Well, we briefly touched in the interview on Mount Hood. Is that relevant? 'Cause it says the acidic dome.
Okay.
Apron, but we're not really talking about that. If it is a source.
Let's try it verbally. Thank you. You stuck right to the end of that with Gary. And I asked Gary, what can I visualize up in the Cascades, Gary, for the volcano itself? Is it a big Mount Rainier? And he said, let's not get carried away. I don't want to imagine Mount Rainier as the source of all the dacite that's being dumped between, we'll go back to his numbers, 11 and 7. But he said, I kind of like Mount Hood. Mount Hood is not as massive as Mount Rainier. I'm like, that's okay. You know, I'm just asking, is there a big cone there or not? He's like, well, Mount Hood, somebody can correct me if you heard it differently. I think he said Mount Hood, down by Portland, was active recently, like in the last 30,000 years maybe, he said. Somebody have that? Oh, yeah, okay. That was the most recent little blurb of pumice coming down the Sandy River. It's literally called Sandy River because of the pumice in the river. I'm talking about, yes, maybe tens of thousands of years, maybe even hundreds of thousands of years earlier in Hood's activity, there was a lava dome, as I visualized it, in a crater. Sound familiar? Mount St. Helens is a cone that blew out. Are you aware of Mount St. Helens? 1980 had an eruption. Some of us were alive. So in the crater of Mount St. Helens, you all know this, there's a dome that was active in the early 1980s and built. That's dacite, baby. The dome inside of the Mount St. Helens crater is a dacite dome. And it was active again between 2004 and 2008. And there was all sorts of excitement around here, and everybody's coming to my office. We're using this internet, and I'm like, I don't have Google. I have $100 a month. Somebody lend me some money, and then I had a door-to-door salesman come to my house and say they could. Okay, I'm giving up on the Google gig. Okay. If you have a dome of lava, I guess whether you're inside of a bigger crater or not, and there's some kind of slope, downslope, going away from that dacite dome, and you collapse that dome. This is where I need James, but he's on his walk to get his steps in this morning. You collapse the dacite dome, you dump a bunch of stuff into a nearby valley. And this is what I'm ultimately wanting to go with you right now. In the fine print, I'm going to try to draw this in a second. There are two completely different kinds of deposits that are in the upper Ellensburg. Does anybody want to try this? What are the two major alternating stories in this blue sandbox? And I'm going to try to draw it while you're talking. Anybody want to try it? Some of you are really locked in, others are on Mars, and I'm not going to be able to reach you. I understand that. Too vague for you? Try it, Julie.
Was it Dacite basalt?
Not what I'm looking for. We have volcaniclastic. Let's do it. We have a volcaniclastic pile between 11 and 7 according to Gary's numbers. And so we don't have any lava flows. I don't think that's what you're saying, but whatever. And we're ignoring the basaltic cobbles. That's just a local knuckling up. Jack. Okay, let's try that. So I'll make this up. There's many more packages of this, but let's just have fluvial. I'm going to have to go to my notes here in a second. What does fluvial mean again? River. And presumably, I'm going to use Old Scab Mountain, even though nobody had it ready to go. I'm going to use Old Scab Mountain as the source, because I've got another Gary Smith paper that I'll probably give you this weekend that's going to say that. And I have a master's thesis that's going to confirm that as well. So Old Scab Mountain near Bumping Lake is our source. So when I say fluvial, everything's blue here, right? Today's topic is Cascade, yes. So if we have fluvial interbedded with non-fluvial, whatever the hell that would be, I'm saying that the rivers are coming from the Old Scab Mountain. Does anybody have the detail about what's in the fluvial? We can do a Geology 101 answer, or we could add some more. What's the 101 answer? It's fluvial. These look like rounded river rocks. So they look like, is this a river rock? Yeah. I just did that on Menashtash Ridge an hour ago. So we have a conglomerate. But what about the conglomerate is helpful to us? Is it monolithologic, or what's the other word for the opposite of monolithologic? Polymythologic. Polylithologic is what Gary was saying. Which do you suppose is true here? Got a 50-50 shot. Maybe I read this wrong, but I think he's saying there are some beautiful, coarse conglomerates in the upper Ellensburg in each of these basins. Sela Basin, Weenass Basin, Nile Basin, Thorpe Basin. Hang on, Julie. And they are polymictic, different stones, different colors. I mean, it's a valley. It's a valley with streams coming in. There's different parts of the Cascades that are drained. I don't think this should be a surprise to us. Julie?
Didn't you say there was all older volcanic material, including like the
Okay, that's to the unroofing thing that we're saving till Thursday, but yes, good. Okay, so I'm building the suspense now. Well, we're writing a screenplay together. We're going to kill the heroin at the end. That's right, I said heroin.
Goes right along with your
Laced ice cream. Like they're giving away free ice cream laced with heroin and meth over in the Cirque. This guy had kind of a faraway look in his eyes. Didn't like him. Sketchy. That's what the drug dealers look like these days. Not in my day. All right. I don't know who got us on this, but I'm coming to you right now in the last 5 minutes. I can just write Dacite interbedded with the fluvial stuff, but I'm leaning to the big finish here. What does this Dacite and Dacite look like? It's monolithologic, meaning everything's Dacite, but what is it? What does it look like? We have to have this. You have strat columns, you have words, you have Gary talking nonstop. Ryan?
He said that it was debris in the video.
Okay, so that's a weird kind of loose term, debris. Let's build on that. Chris, give us an example of debris that is coming from the Cascades. What does it look like?
I thought he said it was lithic debris from the dome's collapse.
Yes? Okay, so that's what I'm ultimately going for. We have flows. This is called Dacite on the Move, baby. That's the title, Dacite on the Move. How are we moving it? I don't really think we're moving it by rivers, primarily. The sources are close by, and we are flowing this Dacite into place. We know what pyroclastic flows are. James and I Googled for $100 a month, still nothing, what a block and ash flow was. But a block and ash flow is a Dacite dome that collapses and starts flowing away from the collapsed zone. What's a far more common way to flow material away from the Cascades? Yes. So Ryan, thank you for debris flow, and I just don't give a shit about debating between, is this a debris flow? Is this a hyper-concentrated debris flow? Is this a lahar? You know, there's 17 terms. I don't care. I just want to know that it's monolithologic. I didn't have that before. Until yesterday I didn't have it. These lahars have nothing but Dacite inside of them. And these pyroclastic flows are monolithologic. It's just, we're blowing up the Dacite domes and getting them out of there. And it's right here. It's right here. Here's Old Scott Mountain right here. Just a few miles from where we're finding this stuff. This is a local story, a dramatic story, a far more dramatic story than I realized. And in between the Dacite chapters are these river things, where suddenly we're just kind of passively bringing in these cobbles. Weirdly, I viewed it the opposite for some reason. I don't know why. I just saw these big, beautiful river cobbles and I'm like, wow, that's where all the excitement is. These big things, they're gorgeous. I mean, these stones are just, out at Thorpe, they're just pinks and maroons and grays and purples. Like, it's so weird looking. Beautiful. But I think the eye is going to be drawn to these Dacite packages that are nothing but Dacite. And remember, what we're leading towards is, where can I find, there must be a ton of Dacite up in the Cascades. There's not. There's essentially zero. And that's the last, I'm already over. So here's what we're doing on Thursday. I'm going to draw a sketch for you talking about a profile of the Cascades, showing a massive unconformity where all this missing Dacite is located. We're going to talk about this unroofing story that many of you want to talk about, that has an inverse pattern than you would expect. in this blue pile, and I'm going to hear from more of you, some for the first time this entire quarter. Who wants to talk to the home crowd as we leave the room? Gavin? Who's joining Gavin? BA person want to join Gavin? There you go, Luke. Luke and Gavin are going to talk to the home crowd. Thank you. I love you. And goodbye. Thanks, everybody. I'm going to chat with some of you in about 10 minutes, but between now and 10 minutes from now, 2 more CWUers, and you guys,
That's right, yeah.
Luke, you come right there. Gavin, you come in. You can see yourself on the frame. So here's these guys live. Luke, give you one of these as well.
All right.
And I need to give you a mic.
Oh, yeah. Yeah, just clip it on there. Yeah, thank you.
Luke, why don't you start? Why don't you introduce yourself to these guys at home?
Yeah, can do. Hi, everybody. My name's Luke. I guess I'm a second-year geology BA. Yeah, I guess
I'll do myself.
Gavin, go ahead and introduce yourself.
Hi, I'm Gavin Kolomanis. I am a third-year geography student and a geology minor, so I bring a little bit different perspective, but still love to be here. It's a lot of fun.
Nice. Well, I guess, are we supposed to answer questions, right?
Yeah.
I think. Yeah, what questions y'all got? It is a fun class.
Yeah, definitely.
Let's see. Oh. I don't know. I guess what else could we talk about? What year you were, Gavin? You just said.
Third year.
Okay.
I hope to graduate next year, I
Nice.
hope.
Okay. That'll work out. I don't know. What else do we have? How far are you in your geology BA?
This is my last class for my
Nice.
geology minor.
Okay.
But I'll probably still take some for fun. I'm thinking about mineralogy in the fall.
Sure.
Just because, why not?
Exactly. Absolutely. Well, you're here.
But I take a lot of GIS classes dealing with mapping. I do a lot with both ecology work and I do a lot with geology work. So I do mapping, but also do stuff with the geology side of things, which is a lot of fun. Gives me unique perspectives. Do you guys like the field trips?
I guess.
Yes, the field trips are probably the best part about this class.
Yep.
I don't know if it's because they're not graded or anything, but it's just you
exciting.
get to go and enjoy and learn.
Yeah, these are the only field trips that haven't been, they're not structured in a way. He doesn't give you a worksheet and tells you to go fill it out. You know, we get to go explore on our own and find what we want to find, which is the coolest thing ever. We feel like actual geologists in the field, you know, instead of just students on a field trip getting toured around, you know. It means a lot more. It imprints itself on you so much more.
Yeah, and back to one of the questions of where we're from. I'm from the west side of Washington, and what got me into geography was just what I could do anything I wanted with it. It's a growing field. You always need mappers. You can kind of do anything you want. And the geology part, I've always been interested in geology, but I knew if I wanted to do geology, I probably have to get my master's. And personally, I don't want to be in school that long. I love it, but I don't want to be here that long.
Yep. Yeah, I guess what do I want to do with my degree? Man, I've got 2 more years to go. So I don't know. Probably I want to try to get a job, DNR, Forest Service. Hopefully use this degree to get in, work wildland. Yeah, and just work with the Forest Service or DNR or any government organization as long as I can. I'm doing a BA because I don't want to go into any geochem work. Really don't want to work in a lab. I want to be out in the field, you know, 24/7, working with just out in the field, you know, exploring, mapping, you know, whatever they can get me to do. So, I suppose that's probably what I'm going for.
Yeah, so this is a good question. Someone asked, do you guys have access to any GIS training? So I'm actually in a degree that it's a BS in geography with specialization in GIS. So your entire degree evolves around GIS, and we have a whole bunch of professors that do nothing but GIS. This can be anything from the programming side of things to LiDAR to flying drones, but also there is a kind of a minor, but it's a certificate in GIS that allows you to do the same thing, and the professors are really flexible. So And actually, from the geography side of, geology side of things, a lot of these classes do dual credit, so you can also do it as a geologist and get credit for it. So yes, there is a ton of GIS training here on campus, and that's actually what brought me to Central. Central's special because they do a lot of that GIS stuff, and especially on the geography side of things, they have a degree that revolves around it. It's not just a certificate. That's what brought me here, beyond getting to have Nick as a teacher.
Yeah, and I think for GIS with me, I haven't taken any GIS classes yet, but I'll be wrapping up my BA in geology, looks about end of my junior year, so hopefully the entirety of my senior year I'll be working on minor gen eds and hopefully getting a GIS certificate to wrap up a couple credits and fulfill another year. And just another thing to add, you know, can be so helpful with mapping, and for Forest Service DNR, that's what they're looking for. It's a really big plus nowadays. So yeah, can't go wrong with it.
So,
Let's see.
someone asked me if I'm interested in graphics video training. So I don't do, I do some stuff with graphics and videos, but mostly I do stuff on the mapping side. So I use ArcGIS Pro. So that can involve anything from programming new tools into it. Like I'm taking a Python class right now that allows me to integrate my own tools and my own things I want the mapping to do, which is, it's hard, I'm not gonna lie, but it definitely is a plus, being able to do that.
We just got a question on 1 to 10, how hard is a geology major? You know, it depends. It really depends on who you are as a person. For me, I think the hardest part of a geology, if you're doing a BS, the hardest part is the math. I think you're up to, I ran up to pre-calc 2, but I think you have to take up to calc 2 to do the BS in geology. But if you're doing the BA, like I believe me and Gavin are, I only had to run up to pre-calc 2, so it lowers the math requirements and makes it a little bit more doable. But I mean, just in general, the classes are, if you're interested in geology, you will absolutely love it. The more you love the classes, the easier they're gonna be. I mean, mineralogy and any isotope geochem classes will probably kick your ass a little bit, but you know, I remember some late nights in the lab, staying in there till about midnight trying to get stuff done, but that's probably the best experience I've ever had in a class here at Central. So, I mean, you know, difficult, but I mean, more than worth it at any point in time. So I definitely give it, I don't know, a solid 5. You know, it depends in difficultness, but in just what you're learning and the experience you're gaining, solid 10. So.
See, on my side of things, I love math, so math was never an issue for me. For me, it was actually the English side of things. I need to take technical writing, and it's kicking my butt right now. And I'm only a minor, which makes it a lot easier. But even then, it's like the math and the English are probably what's going to get you, and some of the higher up, like chemistry classes that you might need to take as prereqs.
Yep.
But yeah, those are probably the biggest kickers.
Yeah.
Thank you.
So yeah, thank you, Nick. Absolutely,
Yeah.
and thank y'all for the questions too.
Yeah, thank you.
There's that.
Good job.
Get this guy.
Stepping up today, Luke. Good to see you. Thank you. All right, thank you. Bye-bye, you guys. Okay. 101 lab help session. You guys just go ahead and do what you need to do here. Don't ignore me. A couple minutes while some of the 101 students are in here making up some labs. I don't think today worked. I'm not sure how you felt, but I was hunting. I was hunting for something that would just light everybody up, and I was loose on purpose because I thought we would get there, but I don't think we ever really got there. It's late in the quarter and everybody's stressed, blah, 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 midterm exams, we know all that, but like that, I think I know what I want to do on Thursday that will totally work. I just spilled the beans with Julie and Jess, and they'll see that, but it's never a disaster in here because we've built a certain vibe, and it was fun a couple of the people who really did poorly on the midterm were extra verbal today. So they are wanting to make sure that they're in good standing in the class. So happy to see that. A couple uppercase questions from you before we quit today, and open the blinds. There's only 5 more lectures. Thank you, Harriet. Yes, they do have a lot of opportunities here at CW, and some of them really take advantage of them, and others do not. But when they get older, they'll realize how good they had it here. That's my opinion. Many of you still talking to those, Dilly in the comments, you're still talking to the 2 young gentlemen today. Patrick, could repeated explosive caldera lake collapses give the monopoly stratigraphy? Probably. Caldera lake collapses. Well, I just have a vague notion of the old Scab Mountain, and I know there's a couple of mapped calderas up there, but well, that's an interesting thought. Did Paul Hammond map a caldera tied to some of this dacite? I'll have to look into that. I might do, at some point, I'll do a video at Old Scab Mountain, especially, I think, thank you, Peter. I haven't been filming Thursday afternoons. I'm wanting to spend time with the students themselves, but maybe it would be good to get a good look at the dacite in the upper Ellensburg and then go directly to Old Scab and see a whole mountain made out of this stuff. I think that would make a good video. Thank you for the suggestion. Ron, if there's no dacite in this part of the Cascades, what about the tonalite granodiorite? In Gary's paper, he's like, no, I wrote it down, no volcanics or plutonic rocks of the appropriate age have been found. So I guess the answer is not even the tonalite and granodiorite. But as soon as I say that, I need to remember, and I think I need to remind the students again on Thursday, our age dating abilities have just absolutely zoomed ahead. The progress is so wonderful since 45 years ago that I think there's a really good chance that if somebody would like Mike, Eddie, or somebody else came in here and just ran a bunch of the samples through their instrumentation they have now, I think it would be a dramatically new thing. Patrick, there were cascades in the Cascades A to Z. I just haven't tied it to the calderas. The calderas are too old, I think. The calderas in that area were all in the Roaring 20s. Luke, you want to talk more?
Yeah.
Okay. Yeah.
Is there olivine in this? It's cool.
I'm not sure. I don't think olivine should be in this kind of a rock. Yeah.
Green. It's cool though.
I'm still broadcasting. Yeah. Yeah. It's okay. No, we're good. Yeah. All right. Thanks. Thank you. What was Gary Smith on the timing of the Cascade uplift compared to today's understanding? If you go to my website, nickzentner.com, first of all of these papers are available. If you're unaware, it's just like over the winter. nickzentner.com, upper right-hand corner, it says 351. Click on 351. Many of you know this. All these papers are available. If you click on Geology 351 on the main page, you can get to all these videos that we're doing in this class. And the Gary Smith interview is there. Or if you just want to go to YouTube and type in the search box, Gary Smith, Nick Zentner, you'll find this chat I did with Gary. And this was back in December when I was dealing with all the hospital stuff. So I wasn't totally there mentally. But I was ready to absorb the detail. And I think Gary hasn't been thinking about this stuff in 40 years. So I didn't ask him about his old ideas versus the new ideas, because he's literally been in New Mexico for 40 years. And I don't know of anybody who's been really carefully still working on this that was also working 40 years ago. Okay, that's plenty. I need to get out of here. I'll give you one more shot out the window, but thank you for joining us today in Geology 351 land, and I will see you Thursday at noon Pacific.